Ex.2b, we have the integral of 1 over, that is the fifth root of the variable t with respect to t. Okay, as you see the rules, we have the constant rule, we have the constant multiple, we have the power rule, we have the exponential rule. For our case, it's not the exponential, that means the base is not the e. And this is going to be one form of the power function because the variable is t. You have the t here and the t here, but you have to rewrite the radical in form of the power first. The radical, which is the fifth root, is t to the power 1 over 5 with respect to t. The power form, put a note here, for the power rule, it's the integral of x or the t to the power r, not the integral of 1 over x to the power r. So what you have to do, you have to rewrite it as the variable raised to the power. Okay, that means for this case, you have to rewrite it as the integral of t to the power negative 1 over 5 with respect to t. Another way we say, when you have the reciprocal, the power will switch to the opposite side. Okay, so with this form, we have the power function t to the power r, where r is negative 1 over 5, which is the real number, as what we expected for the form of the power function. For the power rule, the integral of x to the power r is x to the power, that number r plus 1, divided by r plus 1. So you just do one computation. You just do whatever the result from adding r by 1, that number is used again as a denominator. And then don't forget to add c for the constant of integration. So nothing to do with the reciprocal form. The power rule has to be x on the top, no reciprocal form, x to whatever the power. The power can be any real number. That means it could be 0, could be negative, or could be positive. So we're going to use a power rule where r is negative 1/2 for this problem. Apply the formula. The variable is t, going to be t again to the power negative 1 over 5 plus 1. Whatever you get, okay, you're going to deal with adding, subtracting the numbers, fraction numbers a lot too for this chapter. So 1 as 5 over 5, negative 1 plus 5, that becomes 4 over 5. Okay, you can check my algebra. If I miss anything, you just let me know. Okay, so put the note here if you need more detail. That's negative 1 over 5 plus 5 over 5. So negative 1 plus 5 over 5 becomes 4 over 5. So the final sum is 4 over 5. I'm going to reuse this number again as the denominator. And then plus c. Okay, I have the complex fraction. The algebra skill that we use all the time. Whatever the quantity divided by the fraction, like for example, divided by a over b. This one means the quantity divided by a over b. Rewrite the division into the multiplication of the reciprocal. Okay, for this case, our a over b is 4 over 5. So then the antiderivative will be in the form of t to the power 4 over 5 multiplied by 5 over 4, and then plus c. And right in the better form, we write the coefficient first, 5 over 4 times t to the 4/5 power, and then plus c as a solution for this problem, or is the antiderivative of 1 over the fifth root of t with respect to t. Okay, so this is the answer. And again, you can check your answer by finding the derivative with respect to t of 5 over 4 times t to the 4 over 5 plus c. The constant multiple times the derivative of the t to the power, which is 4 over 5, t to the 4 over 5 minus 1, and then plus c. These two numbers reduce to be t to the power negative 1/5, and then actually the derivative of the c is 0. So the zero is gone. So it's the same as the integrand. So you are good. Or another way we say we get the correct answer.